Welcome to the Bare Metal Cyber Security Plus podcast. This series helps you prepare for the CompTIA Security Plus exam with focused explanations and practical context. For a companion study guide, check out the Achieve CompTIA Security Plus 701 Exam Success by Dr. Jason Edwards. It is the most concise and complete Security Plus guide on the market, built for busy professionals who want to pass the exam fast and on their first try. You can find this book and others at cyberauthor.me. In this episode, we are diving into some of the most important tools and techniques used to protect data across its entire lifecycle. Specifically, we will cover geographic restrictions, encryption, and hashing. These methods are essential to the Security Plus exam and just as vital in the real world. Whether data is being stored, transmitted, or processed, securing it is not just a best practice, it is a requirement for maintaining confidentiality, integrity, and compliance. Let us start with geographic restrictions. This technique focuses on controlling where data can be accessed from, or where it is allowed to reside. The goal is to enforce security and compliance by limiting access based on physical location. One common approach is called geo-IP blocking. This method uses the Internet Protocol address of an incoming connection to determine the geographic region it originates from. If the region is not authorized, access is blocked. For example, a company might restrict access to its internal systems so that they are only reachable from devices located in North America. This helps reduce the attack surface by blocking traffic from countries where the company does not operate or where cyber threats are known to originate. Beyond GOP blocking, geographic restrictions can also take the form of data residency or regional handling policies. These policies might require that customer data never leaves a specific country, or that certain types of processing only occur within a designated region. A real-world example is when a financial firm based in the United Kingdom uses cloud services configured to store and process all sensitive client data inside the European Union to comply with the General Data Protection Regulation. Even though the cloud provider may have global data centers, the system is set up to enforce that data never crosses regional borders. Geographic restrictions like these are often combined with encryption and logging to build a multi-layered defense that meets legal and operational requirements. Now let us move to encryption. Encryption is the process of converting readable data into an unreadable format so that only someone with the correct decryption key can access the original content. There are two main types of encryption: symmetric and asymmetric. In symmetric encryption, the same key is used for both encrypting and decrypting the data. This method is typically faster and is used in scenarios like encrypting large files or full hard drive. In asymmetric encryption, two separate keys are used: a public key for encryption and a private key for decryption. This approach is often used in secure email communication, digital certificates, and secure web browsing. Each type has its strengths, and choosing the right one depends on the situation. Let us look at some real-world applications. A company might use symmetric encryption to protect its database of customer records. The encryption key is carefully managed and access is tightly controlled, ensuring that only approved systems can read the data. In another case, when a user visits a secure website, their browser and the server use asymmetric encryption to exchange session keys during the handshake process. Once that session is established, the actual data transmission is encrypted using symmetric methods for speed and efficiency. This combination, called hybrid encryption, is what powers most modern secure web connections. These examples show how encryption is deployed strategically based on the balance of speed, complexity, and sensitivity of the data involved. Encryption has proven time and again to be a powerful defense mechanism. In one case, a laptop containing sensitive employee records was stolen from a parked vehicle. Because the drive was encrypted, the company did not suffer a data breach, and there was no legal requirement to notify affected individuals. In contrast, in cases where encryption was not used and data was stolen, the companies faced not only legal penalties, but also severe damage to their reputation. These scenarios reinforce the point that encryption is more than just a checkbox. It is a frontline defense that can prevent a bad situation from becoming catastrophic. Next, let us talk about hashing. Hashing is a technique used to verify the integrity of data. Unlike encryption, which is reversible with the right key, hashing is a one-way process. When data is hashed, it is transformed into a fixed-length string of characters that represents the original content. If even one character in the original data changes, the hash value will be completely different. This makes hashing ideal for verifying whether a file or message has been altered. For example, software vendors often publish the hash value of a file next to the download link. After you download the file, you can hash it yourself and compare the result. If the hashes match, the file has not been tampered with. Hashing is also critical in storing sensitive data, especially passwords. Instead of saving the actual password in a database, systems store the hash of the password. When a user logs in, the system hashes the entered password and compares it to the stored hash. If they match, access is granted. Even if an attacker manages to steal the password database, they will only see the hash values, not the actual Techniques like salting, which involves adding a random string to each password before hashing it, make it even harder for attackers to use pre-computed hash tables to guess passwords. There are many examples of how hashing protects sensitive data. In one case, a university's database of user credentials was breached. Fortunately, the passwords were hashed and salted, making it impractical for the attackers to reverse engineer the actual login information. As a result, the breach did not lead to widespread account takeovers. In contrast, another organization stored passwords in plain text, and when the system was compromised, user accounts were instantly exposed. This difference in outcomes highlights why hashing is a best practice in every industry. For the Security Plus exam, be prepared to explain the differences between encryption and hashing. Encryption protects data confidentiality and is reversible with the correct key. Hashing protects integrity and is not reversible. You should also be able to match encryption types with the correct use cases, such as using symmetric encryption for data storage and asymmetric encryption for secure communications. Similarly, recognize how hashing is used to verify file integrity and protect passwords in databases. Here is a tip to help you succeed on the exam. When a question includes the phrase, "protect data from unauthorized access," it is pointing toward encryption. If it mentions verify data has not been altered, that is a clue it is about hashing. And if it talks about blocking access based on country or region, the focus is likely on geographic restrictions. Watch for these key words to quickly identify which data protection method is being referenced. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.